Okay, I think we've reached quorum, so I'll get started. Hello again, everyone. I'm James Postievsky. I'm the chair of the Systematic Review and Meta-Analysis SIG of AERA. Welcome to our last meeting of 2023. And today I'm really pleased that we're joined by Katie Fitzgerald. Katie is an assistant professor at Azusa Pacific University in the Department of Math, Physics, and Statistics. She has a PhD in stats from Northwestern University, also my alma mater. And her work focuses on both evidence synthesis, data visualization, and statistical cognition. And the topic that she's going to be sharing with us today really, I think, brings all of those strands of her work together. I'm really interested to hear what she's going to share with us, and so I will just pass it right over. Take it away, Katie.
Awesome, thanks, James. Let me go ahead and get my screen shared here. Great, are we good there? See my screen? Okay, awesome. So most of this work has been done joint with my mentor and collaborator, Beth Tipton at Northwestern. And more recently, I've had some great student researchers at APU working with me. So that's David Kella and Avery Charles. And this talk is going to be kind of an integration of a lot of the ideas that James mentioned. And so really, I'm going to kind of do an integration of two different papers that Beth and I have written recently. So the first one was from last year, where we presented a new visualization, the MARC plot, as an alternative to a forest plot. And so I'll kind of work through, what does the evidence say about why a forest plot might not be the best choice when we're communicating to decision makers. And then the second paper, which came out this year, is a framework for thinking about knowledge mobilization as a problem that's worth studying. And what's kind of the types of research that we as statisticians and methodologists in the ed research community need to be conducting in order to kind of move towards more statistical, evidence-based statistical communication practices. And finally, I do have some new MARC plot updates to share for visualizing large meta-analyses, and you guys will be the first to see that. So I look forward to sharing that at the end. So let me get us started with some framing. So I think in the ed research context, we of course all know that we have this substantial body of evidence, right, about quote unquote what works. And so really high quality causal inference studies have become the normal science in a lot of ed research. But in recent years, there's kind of been this growing conversation in the ed community, especially among folks that are studying research practice partnerships, that we really need to be paying attention to evidence use and knowledge mobilization. And they've been quick to point out that just because evidence exists doesn't mean that it's automatically used or useful to practitioners. And really trying to understand how evidence is used and how to make it more useful is kind of a non-trivial problem that's worth thinking about. And so what would be an example of this? Like, what's something that might complicate this research to practice pipeline? And what would be a reason for why it's not just as simple as kind of putting evidence out into the world? I think there's a lot of answers to that question, right? Some arguably more important than the one that I'm going to focus in on, but I'm going to kind of take us to our little corner of the world, right? So as statisticians and methodologists, how does this problem manifest itself? And so if we think about, we're wanting education decision makers to consult the research and make evidence-based decisions. That means we're really we're asking them to make sense of things like effect sizes and their uncertainty. And especially as the body of evidence grows, increasingly what we're asking them to do is to make sense of a collection of studies, right? So this is an example, this screenshot over here from the What Works Clearinghouse is kind of summarizing what does the evidence from 5 different studies say about a particular intervention. So whether we realize it explicitly or not, really we're asking people to reason meta-analytically about evidence. It turns out we don't know very much about are people good at meta-analytic reasoning? There's very little data on that, but we do know that people are pretty bad at statistical reasoning in general, right? And so given the fact that meta-analysis kind of combines a lot of statistical ideas, there might be cause for concern here. But an additional dimension of the problem is that most common visualizations that are being used to display meta-analytic data don't follow data viz best practices. Okay, and in a little bit, I'll get into some of the specifics of what I mean by that and kind of some of the cognitive pitfalls that we need to avoid when we're visualizing and tips for doing better. But before we get there, I want to kind of zoom out and frame the problem more broadly. So the overarching question that we're concerned with here is, how do people reason about the evidence that we put in front of them? And are there ways that we can kind of improve that? And I think as I was kind of in the thick of thinking about this problem, the National Academies came out with this report in 2022 where they really put some useful language to this problem, and they kind of identified it as knowledge mobilization. And they said that knowledge mobilization is actually one of 5 types of research that we need in the ed research community as we think about, what should the future be as we move towards kind of a more equity-oriented science. And they identified knowledge mobilization and kind of defined it in part as studying how do we get promising evidence into decision makers' hands? How do they harness that evidence to guide their action? And how are they currently using it? What are the conditions that would support more centrally and substantively using evidence in their decision making? And so they had this call in the report that strategies to mobilize knowledge need to be studied directly. Okay, or another way of putting that is that IES, so the Institute for Education Sciences, should prioritize research on research use itself. And so in addition to kind of trying to tackle some specific data visualization problems, Beth and I kind of wanted to respond to this call of knowledge mobilization more broadly. So we were really trying to answer the question, how might we structure these knowledge mobilization studies, right? So if this is something worth studying, how do we go about studying it? And so again, if we're kind of thinking about our particular corner of the world, our little slice of knowledge mobilization, which is how do we communicate statistical evidence more specifically? And we don't do this because we think that that's like the most important slice of this problem, but that's just our own area of expertise. And so our goal is really, can we arrive at more effective evidence-based statistical communication practices in education? And if that's our goal, what are the types of studies, what's the type of evidence we need to move us towards that goal? And so we present a framework that we think is really useful to kind of organize ourselves around as a research community. And so we think that there are 3 types of knowledge mobilization research that needs to be done. So kind of normative, descriptive, and prescriptive are the 3 facets here. And this framework's not something we came up with. So it actually originated in the decision-making literature back in the 80s. And then it was adapted to the statistical cognition context about 15 years ago, which this is a really excellent paper, by the way. I definitely recommend reading it. But in its simplest form, this framework is kind of asking 3 questions, right? So how should people evaluate statistical evidence? How do people evaluate statistical evidence? And then can we help facilitate better evaluations of the evidence, right? And often when we consider the normative and the descriptive in concert with one another, so in other words, when we look explicitly at what are the norms baked into how people should be interpreting the evidence, and then we also collect data on how are people interpreting the evidence, often we illuminate there's a gap between those things. The people are not, the way they should is not in line with the way they do, right? And so the kind of linchpin of the knowledge mobilization framework then is, once we've illuminated those gaps, how can we create better strategies, more effective strategies to kind of bridge that gap and facilitate better evaluations of the evidence? And so another way of thinking about this framework is kind of as a call to action, right? So we need 3 things. We need to examine the norms that are embedded in what we're trying to communicate. So what statistical ideas are kind of baked into what we're trying to communicate. And then we need to descriptively understand how does decision makers reason about that evidence? And we need to descriptively understand what are their decision-making needs, and is the information we're putting out there meeting those needs? And then finally, prescriptively, we need to develop and evaluate communication strategies that are going to facilitate better use of the evidence by decision makers. So let me give you a case study to kind of demonstrate how this normative, descriptive, prescriptive thing might play out. So this is a screenshot, that same screenshot from the What Works Clearinghouse, for how evidence for 5 studies on a particular intervention might be displayed. So at top, we have a meta-analytic effect size of 4 that's kind of summarizing the 5 studies below it. So here, when we think through, how should people reason about a collection of studies, the What Works Clearinghouse is following statistical norms that have kind of established, okay, we know meta-analysis is the gold standard way for evidence synthesis, right? And so they're combining those studies as a weighted average with weights, inverse variance weights. And we have also norms embedded in how the effect size is being represented, right? So we've got the improvement index here, which is kind of based on an argument by researchers that this is maybe easier to interpret than other effect sizes. But we also have norms embedded in what's not presented here, right? So in order for studies to make it into the What Works clearinghouse, they have to meet kind of a high level of methodological rigor. And those criteria are set by researchers, right? And usually they're focused on trying to ensure high internal validity. We have sample size information displayed here, but not other study characteristics, which again may reflect researchers' norms that tend to put a higher premium on internal versus external validity. And so all of these choices about what gets displayed here, how it gets displayed, all kind of reflect implicit norms that researchers have about the appropriate ways to reason about evidence. And then by contrast, descriptive questions are going to ask, how do decision makers make sense of this information, right? How do they make sense of the 6 lines of research that are presented here? Do they primarily consider just the summary effect at the top? Or do they kind of make ad hoc syntheses of the individual 5 studies in some way? How do they interpret the improvement index? Are they trying to kind of search in the studies a little bit more to find which one is in a context that's most similar to mine? And if they identify that, do they kind of hone in just on that study and ignore the rest of the evidence? Or are they kind of, again, making these ad hoc syntheses in some way? And so we really need to kind of get a pulse on how are people engaging with this type of information that we put in front of them. And again, one of the advantages of this framework is considering the normative and descriptive together. The natural question becomes, is there a gap between the two, right? But one thing I want to highlight here is that the gaps between the intended use and the actual use of an information display are not always the result of decision maker misunderstanding, right? So gaps can also exist when researchers misunderstand the information that's needed for decision making. And so when we think about the prescriptive work as almost being like an intervention, it could be an intervention on both parties, right? That researchers need to change their practices and how they're communicating and what they're communicating. And then decision makers may need some help to interpret the information according to statistical norms, for example. So really, at the heart of this idea is we think that knowledge mobilization is an invitation for us as researchers to be more evidence-based in our own practices. And we think this framework can help, right? So we, in the education community, we're an evidence-based field. We like to tout that a lot, and we're really good at conducting research to determine best practices for other people. And so we're kind of asking us to, let's make our own practices the subject of study and see if we can't turn some of our research tools into developing more effective strategies for our own communication practices. And so if we're trying to be more evidence-based, what evidence should we be turning to, right? And where do we need to generate new evidence? And so I think that there are at least 3 literatures that are useful when it comes to communicating statistical evidence. And so the data visualization, cognitive science, and then HCI, which is human-computer interaction. And so I'm going to highlight some specific tips from those literatures in a second, but I think these fields actually, the way they go about establishing best practices have some broader lessons for us as well. And the first is that they are very aware of the curse of expertise, right? So the curse of expertise is this very well-documented psychological phenomenon that suggests that we severely overestimate the extent to which other people hold the same knowledge that we do and are going to see the world the same way that we do. So if you have some level of expertise, it can be very difficult to imagine what a naive person who doesn't have that same knowledge, how they're going to see the information and interpret the information that you present to them. So once you understand this, once you're aware of the curse of expertise, we're a lot quicker to realize that, oh, the message sent might not be the message received, right? And so part of why I think these other literatures and research communities are really good at this is because they spend a lot of time doing descriptive work, right? So they don't just put information out into the world, they put information out into the world and then they collect data on how is this being interpreted? How do people understand this? What are the cognitive pitfalls and that sort of a thing? So let me give a couple examples of this. So I think we all know or probably have heard that p-values are notoriously misunderstood, right? But much to my dismay, confidence intervals are also prone to a lot of misconceptions. So when I started digging into the literature there's particularly when confidence intervals are depicted visually, there's a lot of evidence to suggest that people are really bad at interpreting those and reasoning about error bars. So error bars don't facilitate appropriate understandings of uncertainty. And often what happens actually is people invoke null hypothesis thinking when they see confidence interval bars. And so they end up interpreting things dichotomously in similarly arbitrary ways to how they interpret p-values, for example. But also, the error bars are often not very well labeled, right? And so it's unclear, are they showing standard errors? Are they showing confidence intervals? What level of confidence? And even if they are well labeled, we don't really, as humans, have very good visual intuition that allows us to conduct inference by eye, as some of these authors kind of label it. And so we're really, error bars are not going to be an effective way of trying to get people to grapple with uncertainty. But then bar plots are also subject to an additional cognitive pitfall, which is something called within the bar bias. Okay, so this is what's depicted in that third panel over there, which is the problem that bar plots are inherently anchored to an axis, and it gives the illusion that values that fall within the bar are more likely than values that fall outside the bar. Okay, and so, for example, that red dot on the left, when we see that, we think that that value is more likely than the red dot on the right, just because one falls within the bar and the other one doesn't. So the fact that these bars are anchored to 0 kind of gives this illusion that uncertainty in one direction is more likely than uncertainty in the other direction, whereas in reality, both of these red dots are exactly one standard error away from their mean, so they're both equally likely values. And so by collecting descriptive evidence on how do people reason about these types of visualizations, these literatures, these communities have been able to establish we really shouldn't be using error bars for uncertainty, and we shouldn't be using bar plots for effect sizes. Okay, and often one of the first steps in the prescriptive piece is to identify what not to do, right? But we don't want to stop there, ideally. We want to push forward and kind of create strategies that do better. And so that's really what that prescriptive piece is about. And that's exactly what these data viz and HCI communities do, right? So they design new visualizations that are kind of informed by all that descriptive evidence about the cognitive pitfalls to avoid. And they try to test the new visualizations against existing ones and see, like, are we able to do better? And they use that as kind of this mechanism for establishing more effective visualizations and best practices. And so, for example, this is a paper that has determined that continuous displays of uncertainty are more effective. So an example of that is a gradient plot that kind of fades out, and a violin plot. Okay, and so they're kind of avoiding that issue of being anchored to an axis, so they don't have the within the bar bias issue. And then it also is able to lead to better and less dichotomous reasoning about uncertainty, because you kind of have this likelihood that fades out as you get farther away from the point estimate. So what about meta-analysis? On the left is kind of a recreation of that What Works Clearinghouse image, right? So that was kind of essentially a bar plot that had effect size and sample size information included on it. And then on the right is a traditional forest plot. Okay, and these are the two most common ways that we see meta-analytic data visualized out in the wild, and both in research papers, of course, but also on clearinghouses that are trying to communicate to education decision makers. And I hope even with just like this brief foray that I've given you into the data viz literature over the last few minutes, you're probably able to identify, yikes, like we're falling prey to some of the cognitive pitfalls here. So on the left, we are using effect sizes for bar plots. And on the right, we are using confidence interval bars for uncertainty, right? So we might have some cause for concern here. But I'm also going to highlight a couple extra issues that we might be concerned about in visualizing meta-analytic data for education specifically. So bar plots are displaying sample size, okay? And it turns out that people actually do have decent intuition about sample size and its relation to uncertainty. So people have, even if they don't have much statistical training, they kind of have some natural intuition that, okay, more data probably means more certain, right? More precise. However, that intuition can actually fail us in education, right? Because often we are conducting cluster randomized trials. And in a CRT, the number of clusters, so the number of schools, is actually what drives the standard error more so than the number of students. Okay, so if we were providing the number of students as sample size information about studies, that can actually be a misleading proxy for uncertainty. And then one other big issue that I think the data viz experts are good at thinking about, which is what are we drawing visual attention to in any given visualization? Okay, and so what are our eyes drawn to? And in both of these visualizations, we are bringing undue visual attention to the wrong things, right? And so what gets the most visual attention in a bar plot? It's the longest bar, right? And so what is the longest bar? It's the largest effect size. So inherently, our eyes are going to be drawn to the largest effect size, regardless of whether or not that effect size has been precisely estimated. Okay, and then a similar issue, but manifested in a different way, on a forest plot, what gets the most visual attention? The longest bar, right? Well, in a meta-analysis, we know that's actually really bad, right? The longest bar means that effect size has the widest confidence interval, which means it was the least precisely estimated effect, which is exactly the study we want people to be paying less attention to, right? And so it's working very counterintuitively, counterproductively to what good meta-analytic reasoning would be. And this is not just a kind of theoretical example or a hypothetical concern. So in our 2022 paper, we put these visualizations in front of education decision makers, and the most common wrong answer. So one of the questions was, which study do you trust the most? And then which study has the most weight? And the most common wrong answer for a bar plot was the study with the largest effect. So their eyes were being drawn to that largest bar. And then in a forest plot, the most common wrong answer was the study with the widest confidence interval. So we have kind of this cognitive pitfall that's actually leading them to poor meta-analytic reasoning, right? And this is kind of a perfect example of the curse of expertise, right? Because we've all been around confidence intervals so long that we know that wide is bad and narrow is good, right? But non-researchers, and in this case, education decision makers in particular, apparently don't share that same intuition, right? So we shouldn't assume that they do. And so for all these reasons, based on both the previous data viz literature as well as our own descriptive evidence, we really caution against using bar plots and forest plots for meta-analytic data, specifically when we're trying to communicate to non-researchers. This is not as much of an issue if we're communicating among experts in meta-analysis, but when we're trying to communicate externally to decision makers, we really need to kind of be careful about these visualization choices. And so I was able to kind of pretty quickly, when I was digging into the literature, discern, even before I conducted these experiments for myself, I could kind of discern that the bar plots and the forest plots were going to have some issues because of all the previous evidence that the data viz literature had documented. But then I came across this great paper by Child and Voracek. It was in RSM in 2015, and they had actually caught on to some similar concerns with the forest plot. Okay, and they were trying to design and evaluate something that would do better. And their solution was the rainforest plot, which is displayed here. And when I saw it, I thought it was pretty promising, right? So they've kind of fixed the confidence interval bar issue. So they're showing continuous displays of uncertainty. And you can tell they've really tried to pay attention to not bringing undue visual attention to things as well, because they've kind of made the least precise studies appear lighter, more transparent and thinner. And they have these raindrops here that are darkest at the center, and they fade out both in height and in transparency as you kind of move farther along the likelihood curve, kind of in a similar visual aesthetic to what a gradient plot is doing. And so I was very convinced, okay, they fixed these big cognitive pitfalls, right? Like this is going to work. And to the author's credit here, the rainforest plot, they did conduct an experiment, and they show that this is better when you're communicating to experts. So this has some improvements over the forest plot because they showed that it was able to help experts reason better about heterogeneity, actually, which was interesting. But when I was kind of, realizing this, I put this visualization. I was talking to some folks that are data viz experts, but they don't work in meta-analysis, and they were kind of like, yeah, I don't know what's going on here. I think other people are going to be really confused by this too. And so I had kind of fallen prey to the curse of expertise, right? Because here I was as a statistician kind of geeking out like, oh, this is really cool. Like the way they've encoded the likelihood curve, and, the likelihood isn't constant across the confidence interval, et cetera. Meanwhile, I'm forgetting that my audience, education decision makers, they don't know anything about likelihood curves. They don't care about likelihood curves, right? And this, rainforest plot kind of follows all the same conventions of a forest plot. And so I'm very familiar with that. I know how to interpret that. But people that aren't already familiar with the conventions of a forest plot, we've kind of made the complications of a forest plot and then just put some even more complicated encodings on top of this. And so I had fallen prey to the curse of expertise here. And the kind of advice from the data viz experts were saying like, yeah, there's way too complicated encodings here. You really kind of need to simplify what's going on. And so they were kind of telling me like, yeah, you gotta, if you're trying to communicate to non-experts, you're gonna have to do better. And so in working with Steve Frankenary, who is a data viz guy at Northwestern, we're really trying to reimagine what would be a better way to communicate this type of meta-analytic data. So what if we tried to kind of free ourselves from the norms and structure of a forest plot and try to think more creatively about what are we actually trying to do here? What are we trying to communicate? And so that really brought me back to the normative question, right? What are the norms that govern meta-analytic reasoning, right? And so really the key idea to meta-analytic reasoning is that more precise effects get more weight, right? If we kind of boil it down, that's the key idea in meta-analysis. And all three of these visualizations are making different choices about how to display meta-analytic weight, right? So we have weight sort of as proxy displayed as sample size in the bar plot. We have it displayed as the size of the square in a forest plot. And then we have it kind of combination of height and transparency in the raindrops here. And so what the data viz literature has established is that we have all of these visual mappings available to us, right? And some of them are better than others. Okay, so for example, this panel over here on the right is showing 5 different visual mappings we have available to us. So 5 different ways of showing that 7 is bigger than 1, for example. So for example, 7 is farther to the right than 1 here. So it's, you know, bigger on the x-axis. 7 is a longer bar than 1 here. 7 is a bigger circle than 1. 7 is a steeper angle than 1, or 7 is a darker dot than 1, right? So there's all these different ways we might choose to embed this numeric information into a visual. And that's really what data visualization is doing, right? But the literature has kind of established there's a hierarchy to these mappings that we have available to us. And these are mapped here from highest to lowest in terms of most powerful to least powerful in how our brains are able to process information and kind of extract differences. And so in the forest plot, for example, we're using area as the mapping, which is a more powerful mapping, a better mapping than intensity. But we're not using, so also they have length kind of implicitly displayed here, right? But it's kind of working counterproductively, right? So anytime you display a confidence interval, you're going to have length at play, and it's going to be working in the opposite direction that you want it to, because the shortest bar is going to be the most weight, the longest bar is going to be the least weight. And so none of these visualizations, though, are using the most powerful mapping we have available to us, which is position, okay? And so our brains are fastest and most accurate at extracting information when it's encoded as position. So position on the X or Y axis. So for example, I am better able to discern that this square is above this square, so it's at a higher position, than I am able to tell that this square is bigger than that square in terms of area. Okay, but in all 3 of these visualizations, the y-axis is not being used to tell us anything that helps us reason about the data or about the evidence. And so often, you know, studies are sorted arbitrarily by author's last name or publication year or something, but there's no like, it's not telling me anything useful to know that A is above B, right? And so we really wanted to think through, okay, if the key to meta-analytic reasoning is that more precise effects get more weight, is there a way that we can kind of reimagine a forest plot that kind of embeds that key idea in a way that utilizes that y-axis position that's currently being wasted? And so this is what brought us to our new visualization. So the meta-analytic rain cloud plot, which we were calling the MARC plot. And our biggest design choice was to put relative weight directly on the y-axis, okay, as a way to utilize the power of that positional encoding and to make that key meta-analytic idea salient. Okay, so other things we tried to do was we tried to kind of simplify our encodings to avoid that cursive expertise as much as possible. So even though, you know, my statistician self was geeking out about those complicated likelihood curves, that's probably not the best choice when we're communicating to non-researchers. And we're also not displaying confidence intervals on individual studies. And we decided to only display uncertainty on the summary effect. Okay, and we chose a continuous display of uncertainty again, and we're kind of showing this cloud of plausible points that represent, you know, the plausible range of values that the true summary effect might be in given the current evidence. And we modeled this actually after the 538 ball swarm plot. Where they're showing kind of the plausible election outcomes. And this is informed by some data viz research that suggests that people are better at reasoning about uncertainty when it's displayed as individual potential outcomes. Okay, and so this is a lesson that they actually learned between the 2016 and the 2020 election, because this is how they used to display their election probabilities. And it turns out that people are really bad at reasoning about uncertainty when it's displayed like this. So people kind of see this and they interpret it very deterministically. So like, oh, 71 is bigger than 28 or 29, so Hillary's going to win this thing. Okay, whereas if you show them, these are 100 possible election results, Trump wins 28 of them, all of a sudden you realize, oh, there's some real uncertainty there, right? This is not a for sure thing. So it kind of kicks our reasoning about uncertainty into gear in a way that helps us reason more appropriately about the uncertainty that's there. And then finally, we took some lessons from the data journalists, which is that you should annotate your visualizations, right? You should guide your users to the desired interpretation. So this sort of helps protect against the curse of expertise, right? So instead of assuming that people know how to make sense of it, teach them how to make sense of it. Okay, so we added this kind of informal legend that studies that are higher up are more certain, studies that are lower down are less certain. And then we kind of added these annotations that, okay, if you get a negative standardized mean difference, that means the intervention decreased scores. We put that in a red region. Red is bad. Okay, and then we put the positive scores blue in a blue region for blue is good, and said that, okay, if you're over here, that means the intervention increased scores. Okay, and so to kind of put it back in the knowledge mobilization framework, what we're really trying to do with the marked plot, and what we think we should be doing with all attempts at communication, is we should look at the descriptive evidence. What are the cognitive pitfalls? How do people reason about these different design features? And then we combine that with thinking explicitly about, the normative facet, and what are the norms that we want people to follow as they're interpreting this evidence, and can we kind of prescriptively combine those two to design a better visualization that bridges that gap and kind of helps guide them to a more appropriate interpretation of the evidence. And so, of course, we hope that there's some good theoretical reasons to think that marked plot might do better, but we wanted to actually evaluate it, right? And so we did a randomized survey experiment where our main factor was the 4 visualizations, and we randomly assigned participants to view different visualizations, displaying various meta-analytic data sets. And we had 83 education practitioners and 94 education researchers in this particular sample. And we asked them 7 basic questions that were essentially asking them to extract information from the visualizations to see if they could understand what was being displayed. And so I'm going to highlight 2 particular things here. First is the question that asks which study was given the most weight in determining the summary standardized mean difference. And this is where the marked plot really excelled, right? So 95% of people were able to answer that correctly. And at first you might think like, okay, duh, the weight was depicted directly on the marked plot, right? But to me, the more important finding here is just how few people were able to answer that correctly on all the other visualizations, right? So they were not able to discern that when weight was depicted as sample size or as the size of the square, for example. And so to me, this kind of illustrates the curse of expertise, right? Less than 6 in 10 people were able to answer that correctly. They were, they're not well acquainted with forest plots, so they don't have that natural intuition that large square means larger weight. Okay, that encoding is not obvious to non-researchers. The second thing to highlight here is that positional encodings really work. Okay, so all 4 visualizations have standardized mean difference on the x-axis. So any questions that ask them to extract things about the standardized mean difference, upwards of 80% of people were able to do that regardless of how it was displayed, so regardless of the visualization. And so to me, the benefit of the marked plot is that we're kind of additionally taking advantage of the other positional encoding to tell us something useful about the data in a way that the other visualizations weren't doing. So we did find that the marked plots perform better. So these are kind of, we've got the average score of participants when they were answering those questions on the y-axis, and we do have marked plots as the highest average score, and those differences with the other visualizations were statistically significant. We have an effect size of roughly 0.7 or 0.8 for the difference, the advantage over the forest plot, and then the advantage over the bar plot was about 0.4. And the thing we're really proud of, though, is that we were able to kind of bring practitioner scores up to a level that was comparable with researcher scores. Okay, so we had this kind of control sample of researchers that were able to, they did score better than practitioners in every case, but for the marked plot, practitioner scores were brought up to a level that helped them reason similar to the way that researchers were reasoning about the evidence. So kind of these simple design changes really helped change the way that practitioners were able to engage with the evidence. So, okay, awesome. This is where, our 2022 paper left off. We have this new visualization. We've demonstrated that it does better, but so far we'd only tested it with a small number of studies, so with K equals 5. And that is pretty typical of the education clearinghouse scenario, but it certainly doesn't cover all the scenarios where we might want to visualize meta-analytic data, right? And so it was actually a reviewer on our 2022 paper was the first one to raise a concern about what's going to happen with larger K, right? Because if we have relative weight on the y-axis, as you increase the number of studies, inherently your relative weight is going to shrink for all of the studies. And so you're going to kind of end up with this pooling of studies at the bottom. And we were concerned, like maybe we'll lose some of the advantage of what that y-axis position is really telling us in a marked plot. And on the one hand, we were thinking, okay, well, maybe it could help communicate that like all these studies are roughly contributing similarly to the overall effect. But you could pretty quickly tell that this might become cluttered and difficult to read, right? So we wanted to see if we could create an extension of the original marked plot that might do better for large meta-analyses. So this is where I looped my student researchers in, and we kind of landed on this version where we've kind of split the axis. So we've put the summary of the evidence up on a different plane, which the disadvantage to that is you no longer have this like continuous display that the summary effect is equivalent to a weight of 1. But the advantage is that we've kind of allowed there to be some of that vertical separation again. So there's less clutter and less pooling down at the bottom by kind of being able to zoom in on that y-axis and create that separation again. So we tested this in another experiment, and this is hot off the press. We haven't disseminated these results anywhere yet, but we were testing to see how do these marked plots do against bar plots and forest plots, and do they still hold up in large meta-analyses? So we had the 4 visualizations crossed with 4 different meta-analytic sizes, so 10, 20, 50, and 100 studies. And a change that we actually made for all of the visualizations, all 4 of them, is we made them interactive, right? Because once you get 50, 100 studies, it becomes really cluttered, even in a bar plot and a forest plot, to label 100 studies or list 100 sample sizes, right? So we changed them all into interactive visualizations so that when you hover over the particular study, it kind of information about that study pops up. And we did find that the marked plot, the advantage of the marked plot does persist for larger K, so for large meta-analyses as well, but only when we used that second version that maintained that y-axis utilization, right? So that does really seem to be the key there. And these are kind of the difference estimates here. The advantage over the forest plot was a Cohen's d of about 0.4. The advantage over the bar plot this time was a Cohen's d of about 0.1, or about 1 actually. And the marked version 2 was significantly better than marked version 1 as well. But interestingly, something that we found was that the forest plot did relatively better than it did in the previous experiment, which we largely attribute to the fact that weight is now visible via that hover text, right? So people don't have the natural intuition, apparently, that large square means a larger weight, but when you provide them with that information in the hover text, they're able to do better in reasoning about the data and the evidence there. But the marked plot does still offer some advantages above and beyond the forest plot still, but the forest plot did do relatively better than it had done previously. Another interesting finding was that the concern about the sample size being a poor proxy in CRTs was not just a hypothetical concern. It actually ended up happening in this experiment. So this was not a contrived example. This naturally happens. So we were randomly generating our meta-analytic data, and it turned out that the study with the smallest standard error was not the study that had the largest student sample size. And so in a bar plot, the users were inherently unable to accurately discern which study gets the most weight. Okay, and so that kind of is what's accounting for the bar plot doing especially worse in this scenario here. And so what are some future directions? We do plan to have an R package on CRAN eventually. We do have kind of a bare bones version is available on GitHub, so that's new. So the link is provided here. So the package is called MarcViz, M-A-R-C, Mark. And it is under construction, but you're welcome to use it and give us feedback about kind of what features you would like to see added. Another direction that we're headed that I'm excited about is thinking about how are we going to encode the other study characteristics, right? So how do we help people reason about subgroup effects and moderators? Okay, and I actually think this is an area where we need descriptive, normative, and prescriptive work here. Okay, so we need to understand how are decision makers currently reasoning about subgroup effects and moderators. And then I think there actually is some normative work that needs to be done here. I don't think the statistical methods fully exist yet for what is the appropriate way to incorporate contextual information, external validity information in the meta-analysis context. Should we be weighting studies differently somehow to kind of incorporate which studies are most like mine? So I think there's actually some interesting statistical work to be done there, but then of course prescriptive work as well. So what are effective ways of visualizing this type of information that helps people reason about subgroup effects and moderators? And then I think we also need to think through how do we visualize information that helps people compare multiple interventions. So, a forest plot and all these other plots we've been showing, including the marked plot, is showing a single intervention, right? And just a bunch of studies that evaluated a single intervention. But often in a decision-making process, people might be comparing multiple interventions. Should I adopt intervention A or intervention B? And so what are some visuals that we can that help people reason about that as well? And we've looped in Alex Kale, who I think you guys had speak at this event a couple months ago, as another data viz guy that's really putting his brain towards helping us think about this. So we're excited for some future directions there. So some key takeaways, I think we need to beware of the curse of expertise. I think we as researchers need to evaluate our own norms, examine our own norms, and evaluate our own practices and kind of turn the tables on ourselves a little bit. And we need more evidence. We need more descriptive evidence on how are decision makers engaging with this meta-analytic evidence. What are their meta-analytic reasoning skills? What are the cognitive pitfalls? And what are their decision-making needs? And is the evidence we're putting out there meeting those needs or not? And then I think we really need healthy feedback loops between these three things, right? The normative, the descriptive, and the prescriptive. So we need kind of this integrated science that's going to help us establish best practices for mobilizing knowledge. So that's where I will stop. This is my email and Twitter. Again, the URL for the Mark package. And then I'd be happy to answer questions. And I'm also curious to hear from you guys what visualization and kind of evidence communication scenarios you think are important that you would like to see tackled.
Great, thank you so much, Katie. This is super cool. We've got a good amount of time for questions, so please feel free to post your questions in the chat or use the raise hand feature in the control panel of Zoom, and we'll call on you and you can pose a question for yourself. Dr. Dewey, I see your hand is up.
All right, you might as well be able to see me. When I was looking at your mark plots, I was struck by the way in which they resembled funnel plots, where you have the x-axis, you've got the same thing on the x-axis, and you've got weight on the y-axis instead of all the very many different things people can put on the y-axis of their funnel plot. But you're presenting them for a different purpose, but I wonder whether you'd like to comment on that.
Yeah, thanks for that. You're right. That's exactly kind of the same form as a funnel plot. And we originally didn't make that connection. So I was kind of doing this in collaboration with people that don't really know much about meta-analysis. But then as we started thinking about it, we're like, oh, wait, this basically is a funnel plot, right? But we kind of made the decision. So a funnel plot typically, has a standard error or some measure of uncertainty on the y-axis. And we kind of decided, well, standard error or variance, people probably don't have a lot of natural intuition about how to reason about that. And even if we put raw weights on the y-axis, there's not as much natural intuition to how to reason about that. So we felt like putting relative weight in particular, people have some sense of, oh, it gets 20% of the overall weight, that sort of thing. So we had made that decision to put relative weight because it was potentially easier to interpret. But you're right, it is it's for a different purpose. And so we kind of had to think through what are the right annotations and stuff to add to the graph to help people arrive at the evaluation of the evidence that we think they're needing for decision-making purposes.
Yeah, I just a quick clarifying question on that same topic. The weights that you're using, are they based on the say, especially in the visualization for a larger number of studies, are those weights based on the like fixed effect weighting or random effects weighting?
So in this case, we did just do fixed effects weighting because of it just simplified the data generating process when we were trying to generate a bunch of meta-analytic data sets. But
Sure.
Theoretically, it could be any weight. So you could very easily put random effects weights on there instead of fixed effects weights.
I mean, do you have any intuition about whether they would sort of function in the same way? Because it seems like the random effects weighting, the studies are all going to be compressed towards each other. Right, the weights are more equal than under fixed effect weighting, which seems like
that's true.
Kind of works against your visualization purpose.
Yeah, so I imagine that's maybe similar to what the concern was with when we start adding more studies, right? Like they're all going to kind of pool at the bottom. So to some extent, the new version of the mark plot allows you to kind of zoom in on that y-axis so that you can still see variation. But then, you probably should make some decisions about, when are we kind of arbitrarily zooming in on the y-axis and making it look like there's variation, even though there's not. Yeah, I think it'd be worth thinking through what would be how would we want decision makers to reason differently about random effects weights, and are we kind of complicating that message at all in terms of how we display it?
Sure. Yeah, maybe it's sort of like, I mean, I wonder, so it sounds like the empirical studies that you've done to test this out were based on simulated data under a fixed effect model. Is that right?
That's right. Yeah.
Okay. Yeah.
Yep.
That makes sense to me as a starting point, because if your audience is like clearinghouses, that's really the model that like the WWC would be using.
Right.
So it seems like the right place to start, but I wonder if like even testing out the same visualizations in situations where there's more heterogeneous effects would produce sort of, different impressions.
Yeah, that's helpful. That's something we can look into. We had talked about it at the beginning and kind of had some of the data viz people were telling us, okay, every visualization shows some information and hides others. And so you kind of have to make a decision about what are the most important things you're trying to communicate. And so at the time we kind of backed off of, okay, decision makers are maybe less interested in heterogeneity than researchers are. But I do think that, especially when we start thinking about subgroup effects and moderators, I do think that, drilling down on heterogeneity and creative ways to incorporate that is a useful direction. So yeah, thanks for that reminder.
And we had a question from Melanie, just kind of a shop talk question. What are your favorite tools for creating visualizations?
Yeah, so originally the data viz people I was working with, they were able to create this the mark plot in Tableau in like 10 minutes and it was really pretty and like awesome, but then it took me a while to recreate it in R, and there are pros and cons to that, right? Because I think usually we're going to want people to be able to visualize this information on their own data. So it probably needs to be connected in some way to some data wrangling tools. And so for me, I think having a visualization package in the same environment where you can do some data wrangling is most valuable. So we built this in R with ggplot. However, when we started moving into the interactive space, we started using Plotly a little bit to facilitate that.
Yep. Sean, I see your hands up.
Perfectly timed to finishing a bite of my sandwich. Thanks. Katie, a huge fan of your line of research on this. I think it's awesome. Something that we at Oregon are looking into in terms of more effectively, hopefully, communicating meta-analysis results is transformations. So Elizabeth Day, who I think was on earlier, she might have had to hop off. She has a UO grant trying to see if different ways of transforming an SMD lead to better interpretations of meta-analytic evidence. So you could think of like the transformational packages or scripts in the metaphor package. Curious if you've explored that, because I think right now this has taken SMDs as normative and then trying to find a better way to visualize those, which I think is terribly important. Curious with your framework, which we're using, by the way, so props to you. Have you thought about like normative, prescriptive, descriptive stuff on transforming effect sizes? James was telling me about POMP at SRI. I've looked into that. So James, if you want to jump in on the POMP stuff, but curious if you thought about transformations.
Yeah, so I'm glad you bring that up because I do think that's a huge area that needs to be tackled. And I had thought about it a little bit when trying to create the marked plots, right? And I do think there's some good arguments for why other effect sizes might be more interpretable. One of the challenges is like the improvement index, for example. When you transform it to a percentile, you no longer have the same distributional characteristics as a standardized mean difference. And so the way you start thinking about a standard error of a percentile has different statistical properties than the standard error of a SMD. And so we kind of set that problem aside for a little bit and decided to just stick with the standardized mean difference. But I do think we need to do work in this area. And so I kind of had this slide here. This is one paper I know that has started to do some descriptive information in this area. And so they presented, so they weren't looking at visuals, but just in general, how are practitioners interpreting different effect sizes? Often months of progress has been touted as one that like, oh, teachers have some natural intuition about months of progress. It turns out that they actually weren't so good at reasoning about months of progress. And this paper actually kind of cautioned against that. And so this paper has some good descriptive evidence of like how people are actually interpreting different effect sizes, but I think there needs to be work in the visualization space on that as well. So I'm glad you guys are thinking about that.
If your inbox is open, we might hit you up and pick your brain.
Yeah, please.
See if we can work on it together. That'd be great.
Yeah.
We had a question from Ellie. Ellie, do you want to hop on, or I'll read your question?
Yeah. Hi. Thank you. Thank you so much for this presentation. So wonderful. I would like to know, you mentioned of the normative practice, in terms of what are the good practices and what should be done. And I think for me, I'm a applied researcher, and I think there's a lot of insecurities of, am I doing the right thing? Like every little decisions, analytical decision, I'm not always sure if it's accurate. So I wonder if you have any guidelines or resources that are that you would recommend to provide this more of a systematic or comprehensive guidelines for applied researchers.
That's a great question, and I'm glad you raised that because I think maybe highlights a need a little bit. I don't know, James, you may know more. Are there good resources for applied researchers in terms of what are the appropriate norms within meta-analysis?
I mean, I always point people towards the handbook of research synthesis and meta-analysis. So the edited volume, Valentine, Cooper, and
the latest one.
But right, that's really, I mean, no disrespect to our elders, but it's kind of old school for one. And I don't think it really touches on the sorts of like the dimensions of practice that Katie was raising in her talk. So I don't have great suggestions.
I feel like there seems to be a need because about the handbook that you mentioned. I did spend a lot of time trying to develop the book. I have to say there are some challenges to understanding is in terms of like the language that's being used. For me, that was a little bit challenging to understand. And what comes to me is sorry, I think I butchered his name, Boristin.
Bornstein, yeah.
Yes, he had like common myth about meta-analysis, and I thought that was a very easy to understand language. So I just try to think if there's any way, and I would hope to be able to contribute to this to this to help apply researchers to be able to yes that book, I love that book so much. I wonder if maybe hoping for maybe a collaboration or to be able to help apply researchers to accurately and to apply and to interpret. Just because it's so consequential, whatever we say, it's gonna make huge impact, and I don't want to be like the bad person putting out wrong information or interpreting wrong.
So two other things that come to mind. One, so I think Alex Kale had presented on, I can't remember the name of his system that he created, but kind of, I think it is geared towards applied researchers and helping them think about the different decision points in a meta-analysis. And I also wonder, I saw Josh on here earlier, I don't know if he's still here, but the meta reviewer, I'm not sure how much it has guides for analysis decisions. He could speak to that, but I think systems that kind of help walk you through the steps, and that could be a place to think about if we're the creators of such tools, how can we build in this kind of like almost pedagogical framework to how to teach people to make the right decisions in those tools. I think that's worth thinking about.
A question from Fred.
Hi, I work for Blueprints for Healthy Youth Development, and
Awesome.
we find that this kind of design for communicating meta-analysis is very, very useful. Our problem, though, is that we're not convinced that practitioners really care about the details of the meta-analysis. They're not concerned about heterogeneity or weight. They want to say, does this work for my kids? Does it work for my school? Does it work for the population I have? So I guess my question is, you deal with the practitioners in your study, how open were they to actually reasoning about meta-analysis results rather than just wanting a yes or no answer, good or bad?
Yeah, I think that question is spot on. So in our particular study, it was just an online survey, so we didn't get a lot of that rich feedback from them, but I think that's exactly the type of descriptive evidence that we need. We need to be talking with them and like, what are the pieces of information they need to make informed decisions? And there's kind of this trade-off that we think about sometimes of simplicity versus transparency. So I think as researchers, we have a tendency to want to provide all the information for the sake of being transparent and helping people make their own decisions. But sometimes the more information you throw at somebody, you can kind of, it's information overload and they kind of get decision paralysis, right? And so sometimes dialing back on the information, you maybe don't present all of the information about heterogeneity and all of that in favor of a more simple communication that might actually be what the practitioners are looking for. But from to be completely honest, we haven't collected that data yet, so that's purely speculation. But I think from what I've heard, I think you're spot on, and I think we need to drill in on that more and get some descriptive evidence there about what are the needs and are we meeting them or not.
We need, I think, to bring the practitioners along to educate them a little bit, as well as bring our methods down to their level.
Yeah, I think that's exactly right. Alex Bowers has done some good work on this, kind of partnerships between data science teams and district leaders. And they often found that, data scientists are good at creating these fancy tools, but often it's not what the practitioners are looking for. So I do think we need better partnerships there.
Thank you.
Fred, could I put you on the spot for a second?
Sure.
Do you have any thoughts or suggestions for Katie or for other researchers who are interested in just getting closer to practitioners, right? Understanding the information needs of the audience that you serve.
I do, but I'm very uncomfortable about it because the main way to do it is to lose information. That is to draw big circles for a program with a big effect size and reliable results, and small circles for one with a small effect size and less reliable results. So it's certainly a balance between simplifying and losing too much information. And I kind of lean toward the simplicity, but I feel uncomfortable about it.
Michael, you had your hand up?
At the end of the seminar on, I think it was called applicability, in the discussion, Wolfgang Fichtbauer suggested that you should look at BLUPs, best linear unbiased predictors, in order, which would combine the overall with the individual studies. So people could pick the study which was most like their circumstances, and then they'd have that predictive element in it, which struck me as it was perhaps worth looking back at the slides for that, and just at the end. I can't remember the name of the presenter, but it was a recent seminar.
Yeah, it was Julia Littell's presentation on generalizability. I think that was just our most recent one. Yeah. Or no, sorry, it was in October.
Okay. Yeah, thanks for highlighting that. I'll definitely look into that.
Yep. We are at time. So I think I should wrap up here and say thank you once again, Katie, for this work. I think right, just based on the questions that we've in discussion here, you're in a direction that seems very, very promising and useful across a really big range of contexts. So keep it up.
Awesome. Thank you. Thanks for the engagement, guys.
Yeah, thank you again. And for